children and viewers. In this video, I am going to explain one more important topic for examinations. That is potentiometer. What is the potentiometer and what is the working principle of potentiometer and what are the uses of potentiometer. So in this video, you are going to know about all these things. So this is a very important, children. In examination point of view, IB examination point of view, it is 8 marks question. Clear? Otherwise, the same question will be asked for 4 marks. And this topic is very important for competitive exams also. So that's why you have to watch the video without any skip and watch the video till the end. So without late, I am going to the topic, children. So here, what is the potentiometer? Generally, we know about that the voltmeter can be used to find out the potential difference between 2 points in a circuit. Voltmeter can be used to measure potential difference between 2 points in a circuit. So then, what is the use of potentiometer even though we have voltmeter? Potentiometer also it is used to find out the potential difference between 2 points of a conductor in the circuit. So when we have voltmeter, what is the necessity to use the potentiometer? So the potentiometer measures the potential difference between 2 points in a circuit without taking any current. Without taking any current from the circuit. That means while we are using the potentiometer in the circuit to measure the potential difference, we do not take any additional current to measure the potential difference. But when we are using the voltmeter in the circuit to show the potential difference between the 2 points of a circuit, voltmeter will take some current from the circuit. That's why there is some loss of current in the circuit. Got my point? Potentiometer do not drag any current to show the potential difference value in that circuit. But the voltmeter will take some value of current to show the potential difference in the circuit. So that's why here the potentiometer should be taken as an ideal voltmeter. An ideal voltmeter. There is no loss of current when it is used in the circuit. When we are using the voltmeter in the circuit, it will take some current to show the value of potential difference. So if anybody can ask you during the practical examination, what's the difference between voltmeter and potentiometer and what are the similarity, means that you have to say these things. Clear? So children, now I am going to the topic clearly here. Potentiometer is a device that should be used to measure the potential difference in the circuit without taking an additional current. Clear? That's why it is taken as some ideal voltmeter. Children, generally the potentiometer should be having like this. So this is one circuit for potentiometer. So children, today I am going to explain the topic. It is comparison of EMF of two cells by using potentiometer. So this is an 8 marks question for you, children. So generally, what is the potentiometer means? Simply the construction of potentiometer should be like this. So look at where I am drawing the diagram. So children, a potentiometer consists of so many wires like this. So many wires, and they are made up of same material and they have same length and they have same resistivity. Potentiometer consists of a long wire. Initially, they place like this, like a column, and there is some gap between the two wires. There is some gap between the ends of the wires. So those gaps should be filled or connected by using the copper strips like that. Now all are in series. All the wires are become now series. Clear, children? Initially, how it can take? All wires should be like this here, and the gap between the ends should be connected by using some copper strips. So now this is a wire of length almost, or it is taken as some 10 pieces or 5 meters or 10 meters like that. Each one is taken as 1 meter length. Children, now this is the starting of the wire, that should be taken as A, and here we are taking now this is the final B or C. To measure the potential difference between these A and C, the circuit should be given like this. Here it is the high voltage battery should be given, and from that here one rheostat. What's that? The rheostat is given. For that here we are having some plug key, and that should be given to the another end. Clear? So from that we are having some galvanometer, and that should be having some jockey. So this is a description or construction of a potentiometer. This potentiometer should be having this circle. Construction should be like this. So wires are there. Gap between the wires should be connected by some copper strips. And again, to make them in series, we are taking some high voltage battery. And this is a rheostat. The rheostat means that should be having some variable resistance. And this is the one plug key. And this is the point C. So this is the general construction of the potentiometer. So after children, from one end of the wire, or from one point here, so we are giving some galvanometer, and this is the jockey. Clear, children? So as usually what I told you in the meter gauge, so we are having some jockey. The jockey should be moves from the point A to the point C on the wire. The jockey should be moves from A to C by keeping at different points on the wire. At particular one point, then the galvanometer will shows the zero deflection. When the galvanometer will shows the zero deflection, then automatically now we are getting some balancing point. For example, at this point we are getting some, for example, I am saying now this is X. Clear? So by keeping the jockey from A to C, we have placed something at this point here, and we are checked whether the galvanometer shows the zero or not. Next, again we are change the position. So by keeping jockey or simply slides the jockey on the wire slowly, and at particular one point where we are reading the galvanometer reading is 0. That point what we call balancing point, and the length of wire is what we call balancing length of the wire. So same thing what I was explaining in case of meter gauge, same thing we have to find out the balancing point. So where we are reading the balancing point, then the potential difference is directly proportional to the length of the wire. The potential difference is directly proportional to the length of the wire. So children, this is the working principle of a potentiometer. Got my point, children? The potentiometer consists of a long wire of equal parts. The ends gaps between the wires should be connected with the copper strips, and finally what we get, the wire should be, we are having long wire, that should be having so many turns, and in between we are having this is the first end of the wire, and C is the second end of the wire. In between them what are giving high voltage battery and rheostat and plug key we are given, and after that we are having some in external circuit what we have. From any one of the point wire we are giving some like this here. This is what galvanometer, and this is the jockey. So and we are finding the balancing point like that here, children. So no need to go for individual working of the potentiometer here. Simply in the examination point of view, you have to write simply one thing, that is what the potential difference across the wire is directly proportional to the length of the wire. For example, the wire what we have taken, that should be here. This is the point A, and what I told you, and this is the point C. The potential between A and C should be taken as is directly proportional to the length of the wire. So here, that is the working principle of a potentiometer. Working principle of a potentiometer is that when the steady current is passes through the wire, because the wire what we have taken, that should be having unit area of cross section. So that is a uniform area of cross section will be taken. So that means they will be having same resistance everywhere. So that's why the same current is passed, the steady current is passes through the wire, then the potential difference between the 2 points of a wire is directly proportional to the length of the wire. Got children? So that should be called here working principle of a potentiometer. You have to remember this very clearly. The potential difference across or between 2 points of a wire is directly proportional to its length when a steady amount of current passes through the circuit. So that's why children here generally you will write V is equals to I rho L. V is equals to I rho L. From that what you write? V by L is equals to I into rho. Clear? So when we are taking potentiometer, what I am telling, the steady current is passes, and we are taking uniform area of cross section is there. The wire is having uniform area of cross section. That's why the resistivity also same. That's why I is constant and rho is also constant. Then V by L is equals to what we write? Constant. That's why here we are writing simply V by L is equals to constant. Here V by L is called nothing but here potential gradient. What is that? Potential gradient. So this is the working principle of a potentiometer. The working principle of a potentiometer can be stated as the potential difference between 2 points of a wire is directly proportional to its length. That is the one definition. We have another definition now. What I told you, V is proportional to L. To equate them, we are writing V is equals to I into rho into L. Children, you can write epsilon also, no problem. V is equals to I rho L. What I told you, V by L is equals to I into rho. V by L and I into rho. What I am telling, we are taking some constant amount of current in the circuit, and rho is the resistivity. The wire what we are taken must be having uniform area of cross section. That's why the resistivity is same. That's why V by L is equals to constant. That means now we can state the working of potentiometer is simply like this. When the steady current is passes through the wire, the potential gradient is constant. The potential gradient is constant. This is also called working principle of a potentiometer. Okay, children. Now I am going to the main topic, children. What we are discussing now here. This is the what is that? Comparison of EMF of two cells by using potentiometer. So comparison of EMF of two cells. So when we have two cells, how we can compare their EMF values? That means which cell is having a high amount of EMF and which is having less amount. How we can compare them? So by using potentiometer, how we can compare the EMFs of two given cells. So that's the topic here, children. So children, for that the circuit is as shown in figure. What's that? We are taking some potentiometer that should be having so many wires. So just I am showing simply here. We are taking some really very less number of wire. So this is the point, starting point of the wire A, and this is the starting point of C. What I told you, already wires we are taken. The gap between the ends should be joined with the copper strips like this. Okay, so that's why here we are having two ends A and C. The primary circuit consists of wire, high voltage battery, and this is what? Rheostat, and this is plug key. Clear, children? So this is the primary circuit. This is the external circuit or secondary circuit. So when the key here I am showing you this is the primary circuit. In that K means key. K means what? Key. When the key is closed, the current passes through the primary circuit. Clear? Children, this is the primary circuit. Here whatever the above thing is secondary circuit and remaining entire thing is primary circuit, children. You have to remember that. In that here some plug key is there, that is key. When the key is closed, the current is passed through the primary circuit. Children, here what is the difference between a resistor and rheostat? Here this is nothing but we are showing this is the RH, that is the rheostat. Generally when we are taking some resistor, that will having some constant value of resistance. That's why it will prevent the constant amount of current when the current is passes through the circuit. The opposition shown by the resistance should be always same. But when we are using some rheostat, the value of resistance will be variable. The value of resistance will be variable. So in our laboratory we have rheostat also there. That's why I will show that one also. So here you have simply now you have to remember that rheostat means it is the device that should be varies the amount of current in the circuit by changing the resistance value. Rheostat has variable resistance value. So children, so this is the primary circuit children. Now the cells which are having some EMF value, some epsilon 1 is the EMF of the first cell and epsilon 2 is the EMF of the second cell. Clear? Epsilon 1 is the EMF of the first cell and epsilon 2 is the EMF of the second cell. So we want to compare EMFs of these two cells. Clear? That's why here I am taking now this is the epsilon 1 first cell and this is epsilon 2. Okay children. So these two cells are going to be compared and these two are given to one two-way system. I am drawing separately here children. This is the first cell and this is the second cell. So now these are given to the like this here. We are having two-way system. This is the 1 and this is the 2 and this is the 3. Nothing but two-way key system. So this is the first, second key and this is third key. Just for example. So this is the main key. Don't bother about that. And this is the key 1 and this is K2. So I am saying this is now K1 and this is K2 and this is K. Clear children? So in addition to that, these are given to be some galvanometer and that should be given to be some jockey. Clear children? So here you have to observe the children here now. When K1 is closed, and K2 is open. Clear? K1 is closed and K2 is open. Already K is closed. Don't worry. So K is closed. When K1 is closed and K2 is open, then the current is passes through the first cell. Clear? And if you can got clarity about this one, you can easily write the answer. Now K2 is closed and K1 is open. K2 is closed and K1 is open. Then the current is passes through the cell 2. Clear? That's why first time if this one K1 is closed and this one is open and current is passes through this like this first cell. And if K1 is open and K2 is closed, now the current is moving like this, second cell. Clear? So if you get the clarity about this one, you can easily write the answer. So after giving the connection children, first we have to go in for one assumption, that is what K is closed. Then the current is passes through the main circuit or primary circuit. And now here what I am telling, K1, this is K1. K1 is closed and K2 is open. Then what you have to do children, current is passes through cell 1 or first cell. So clear? K is closed and K1 is closed, then now K2 is open. Clear? Now after that children, when K2 is open, the current is passes through the first cell. Now we have to find out the balancing point by keeping the jockey at different positions. I already told you jockey is nothing but it is seems like chalk holder and that should be having sharp knife edge. Clear? And now children, that jockey should be moves from the point A to C. That means here slowly we are keeping the jockey from the point A and we are slowly sliding this one. We are changing the position of the jockey at different positions on the wire. So at every, for example, I am keeping here. Now we have to check. After touching the wire by jockey, we have to check the galvanometer shows which reading, 0 or non-zero. And again we have to go for another place. We have to check galvanometer showing 0 or another thing. Like that. So by changing the position of the jockey here, we have to check the reading shown by the galvanometer. For example, here at this point J. Sorry, this is I am saying X. J means jockey. So at this point X, the reading shown by the galvanometer is becomes 0. From A to C, we are moving the jockey at different positions on the wire. At particular one point X, the galvanometer will shows the 0. That means here the bridge is said to be balanced. Now here the circuit is balanced. The galvanometer is going to be 0 means that should be does not takes any current. That simply here it is the balancing point. And the distance from A to X that should be taken as the balancing length. So here this balancing length should be taken as here balancing length. Now what is taken as L1. L1. So children, what we know according to the working principle of potentiometer, what we know, epsilon is proportional to L. Epsilon is proportional to L. That's why here simply according to that what right, the EMF what we are taking here epsilon 1. So epsilon 1 is proportional to the L1. So here I will write epsilon 1 is equals to I rho L1. Clear children? So now it is equation number 1. Clear? Very simple children. K is closed and K1 is closed and K2 is open. Then the current is passes to the primary first cell. After that, what you have to say children? So in this case we have to take galvanometer and jockey as shown like this. Now jockey is moved on the wire to get the balancing point. So by moving the jockey on the wire at particular X point, we are getting the galvanometer is 0. That means it is the balancing point. Then we will write according to the working principle of potentiometer, what we write epsilon 1 is proportional to L1 and epsilon 1 is equals to I rho L1. Equation number 1. So after that children, now here we have to change the terminals like this. Now K is closed and K2 is closed. K2 is closed and K1 is open. K1 is open. Children, K is closed, K1 is open and K2 is closed. Now the current will move to the second cell. Clear? And after that again children, we have to find out the balancing point as I told you before. Simply we have to move the jockey from point A and we have to keep the jockey at different positions up to where you get the balancing point. For example, now in the case of second case, at this point Y, we are getting the balancing point. And again, the distance from A to Y should be taken as L2. Initially from A to X what we have taken L1. Now A to Y what we take L2. So in this case, we will write simply here epsilon is proportional to L is the working principle of potentiometer. Now in this case, we will write epsilon 2 is equals to I rho L2. Now equation number 2. So here again we will take divide 1 divided by 2 we will take. So what is first equation? Epsilon 1 is equals to I rho L1 by epsilon 2 by I rho L2. So epsilon 1 by epsilon 2 is equals to L1 by L2. So this is the formula to compare the EMFs of two given cells. Epsilon 1 by epsilon 2 and L1 by L2. So already we know that children, L1 is means what? we will find the distance from A to X very easily by using the scale. That is L1 is known value, and A to Y also we know that we can measure the distance value by using some scale. That is L2. So already we know about the values of L1, L2. If you can substitute the values of L1, L2 in this equation, we will compare the EMFs of the given cells. So children, so this is about the comparison of EMFs L1 by L2. So epsilon 1 by epsilon 2 is equals to L1 by L2. So in this way, we will compare the EMFs of two given cells. Very simple, children. So we have to understand very two simple logics. What is that? First one, we have to know about the working principle of potentiometer. That is epsilon is proportional to L, or epsilon is equals to I rho L. That is the first point you have to know very clearly. And the second thing is what? The circuit should be as shown in the figure. Clear? And then we are giving some two-way key system. Then you have to, while you are writing the answer very clearly, you must know about the when the current is passes through the first cell and when the current is passed through the second cell. You have to must get clarity. So after circuit, we are having circuit like this. First thing is what? Here first K is closed and K1 is closed and K2 is open. Then the current is passed through the first cell. Then we are finding the balancing point, and we mentioned that there is epsilon 1 is equals to I rho L1. And second thing is what? When second thing, K is closed and K2 is closed, K1 is open. And by moving the jockey on the wire, we will get the balancing point. Then the length is taken as L2. In this case, what, right? Epsilon 2 is equals to I rho L2. So by comparing these two, what you get? Epsilon 1 by epsilon 2 is equals to L1 by L2. So by substituting the values of L1, L2 in this equation, we will compare the EMFs of given two cells by using potentiometer. Okay, children, it's very easy question but important question. So I hope you understand. If you can understand this one, like, share, comment the video and subscribe my channel to get the latest notifications. We will meet in the next video with some other interesting topic. Bye. Take care, children.